Hey, good afternoon, guys. I hope you're doing well. And today I'm going to be showing you how to configure OSPF on a couple routers. OSPF stands for Open Shortest Path First, and it is a link state dynamic routing protocol. And the purpose of OSPF is to form a map of your network, and then it chooses the best, least costing path to the destination, and then it adds that route to your routing table. That's the purpose of OSPF. And the way that it does this is it forms what we call adjacencies. The routers form these friendships with one another where they communicate the connected routes, and it forms the map. All these small communications add up and it creates the map. And these communications are called LSAs, link state advertisements. And the routers send out these LSAs, and it has connected routes, and it has the router ID for the sending router, and that is used to determine who is the designated router and the backup designated router. And the reason we have a DR and a BDR is because if you had what it does is all the routers, like let's say we have 12 routers, one is the DR, one is the BDR. So you have 10 routers, all or 12 routers, all forming adjacencies with one another, and that's all that communication, all those LSAs all the time. That's a ton of congestion. So instead, OSPF does this. It has two routers that are in charge, and those two routers are the only routers that form adjacencies with everybody else. Everybody else just forms adjacencies with the BDR and the DR, and they don't form adjacencies with everybody else. So it lessens the congestion, and it's just really cool. I think it's like a really neat design. So let's get in here. Let's get into the router and let's do some configuration. So we're going to go into router 0, and we're going to go into global configuration mode, and we're going to type in router OSPF, and then we type in a number between 1 and 65,535. I'm going to type in 1, and this number is only unique to the router. It's not unique to the area or the domain. So this router right here, router 1, I could set that router OSPF 1 as well, and that won't mess up router 0 at all. They're unique just to the router. So router OSPF 1, and then now we need to add the networks. So network 192.168.1.0. So we're typing in the networks that are connected to the router. And instead of using the wildcard mask, we use the inverse of that, which is instead of using the subnet mask, we're going to use the wildcard mask, which is the inverse of the subnet mask. So the subnet mask was a /24, so the inverse of /24 is 0.0.0.255. You're just switching the zeros with the 255s. And then the last thing you type in is the area 1. So the area has to match on both routers for them to form an adjacency. So make sure you make the same area each time, if they're in the same area. So we're going to add the next network, 10.1.1.0, and the wildcard mask, and the area. And then now that we've enabled OSPF, we can go into the interface, and we could do some configurations there. We're going to go into serial 0/1/0. Oops, I forgot to go into global configuration mode first. Interface serial 010, and I could do IP OSPF priority. I could set the priority between 1 and 255. I'm going to set it to 255. You could do the cost of the interface, so I'm going to make the cost 4. You could do the hello interval, hello-interval, and this is in seconds, so I'm going to do 2 seconds. But I typed in 0 instead of O. There we go. So it's important to know that the hello interval has to match on both sides for them to form an adjacency as well. So make sure you set it for the same thing at both sides. So how do we check our work? We're going to do a show IP OSPF, and we can see we're running OSPF. We're going to do a show IP protocols, and that'll show us the dynamic routing protocol we're running as well, along with the connected networks for that routing protocol. So this looks good. So let's set up OSPF on the other router. Go into global configuration mode, router OSPF 1. Then we're going to add the networks. Network 223.1.1.0, and don't forget the wildcard mask. Area 1, don't forget the area. All right, now we can go into the interface and do some configurations in the interface. Serial 010. IP Ospf cost will be 4. IP Ospf priority will be 200. IP Ospf hello interval will be 2 seconds. So let's check our work. Show IP Ospf, and we're running Ospf. That looks good. Then we'll do a show IP protocols, and we're running Ospf, and those are our connected networks. There's our router ID. And I think we got a message for, yeah, we did. So we got a message, where is it? Right here. It's a level 5 message. It's saying that we went from loading to full, so an adjacency has formed. So that's good. So one more command, we're going to do a show, or a couple more. We have 2 more. Show IP route. And you can see we already have a dynamically learned route. This O right here means Ospf. And we're learning about the 192.168.1.0 network via the 10.1.1.1 interface outbound serial 010. And we have our administrative distance, which is 110, and our cost, which is 5. So how do we determine cost? It depends on the speed of the link. So if you have a 10 megabit per second link, the cost is 100. If you have a 100 megabit per second link, the cost is 19. If you have a 1 gigabit per second link, the cost is 4. So that's how cost is added up. And the routing table the Ospf chooses the path with the least cost. So that's pretty cool. Everything looks good here. The routing table looks good. We have a dynamically learned route. So let's go to the other router and see what's going on there. Router 0, and we'll do a show IP route. And we have a dynamically learned route. Ospf 223.1.1.0 via 10.1.1.2. And that's great. So this looks good. And then we're going to do one more thing. We're going to do show IP Ospf neighbor. You can just type in N for neighbor. And this shows the adjacencies. So we have our neighbor 223.1.1.1, and the state is full. And it shows this outbound serial interface. So that's the command that shows your neighborships, your adjacencies. So that's good. So let's do one more test. We're going to ping from PC0 to PC1. to 223.1.1.3. And there we go. We have connectivity. We are receiving pings back, and this looks great. So we have connectivity from PC0 to PC1, and the reason we do is because we have a link state dynamic routing protocol adding routes to our router, and that's why it works, and that's how you configure it.